In this exercise, we will apply the basic proportionality theorems. The theorem says if a line is drawn parallel to one side of the triangle, here I am drawing a line here parallel to this side, and this line is intersecting the other two sides at two distinct points here and here. Let's say this is ABC. Then the other two sides are divided in the same ratio, which is AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. This is very easy to remember. This is just like this. If these two lines are parallel, then this ratio, the ratio of these two sides, and the ratio of this one and this one is equal to the ratio of this one and this one. So we have AD by DB is equal to AE by EC. Now the converse of this theorem, converse of basic proportionality theorem, says if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So what the converse of this basic proportionality theorem says is that if we draw a line in such a way that the ratio of these two are equal, that is, if AD by DB is equal to AE by EC, AE by EC, then this line will be parallel to this line. Then DE will be parallel to BC. Now let's see question number 1. In the figures 1 and 2, DE is parallel to BC. This line DE is parallel to BC here, and here also DE is parallel to BC. Find EC in 1 and AD in 2. So here in this first figure we're going to find out EC, and in the second figure we will find out AD. Solution. Okay, let's see the first one here. Here, since the question has given that DE is parallel to BC, we can apply the basic proportionality theorem. That is, since these two are parallel, AD by DB will be equal to AE by EC. So here DE is parallel to BC. Therefore AD by DB will be equal to AE by EC. AD by DB is equal to AE by EC. This is basic proportionality theorem. Now AD is 1.5. AD is 1.5 and DB is 3 and AE is 1 and EC we don't know, so let's call it X. EC is X. Now to make our calculations simple, let's take out this point. So if we remove the point, then since there is one digit after the point, then in the denominator we will put 1 0 here. So this becomes 30 is equal to 1 by X. Now you can cut 15 ones are 15 twos are. So now we get here 1 by 2 is equal to 1 by X. So if you cross multiply, you get X is equal to 2. Now therefore EC is equal to 2 centimeter. Now let's see the second figures. Here in the second figure also, DE is parallel to BC, so therefore AD by DB will be equal to AE by EC. So again here also we're going to write DE is parallel to BC, therefore AD by DB is equal to AE by EC. AE by EC. Now AD is what we're going to find out. So let's call it X or Y, anything will do. So we'll just call it X. Now X by dB is 7.2. dB is 7.2 equal to AE is 1.8. AE is 1.8. And EC is 5.4. Now here 1.8 divided by 5.4. Now after this point there is one digit. After this point there is one digit. So in division, when there is same number of digits after the decimal point, then we can remove the point. So we will get here 54. This is I will show you how we get 18 by 54. 1.8 by 5.4. This one you can write 1.8 is 18 by 10. Again 5.4 is 54 by 10. So 10 cut, you will get 18 by 54. So now we can cut here 18 ones are 18, 18 threes are 54. Now again we will cross multiply. 3x is equal to 7.2 into 1 is 7.2. So now we get x is equal to 7.2 by 3. Now you can cut this. 3 ones are 3, 3 twos are 6, now 1 remainder. Now this becomes 12. So since point number is already taken, so you have to write here point. So 3 fours are 12. So here we get x is equal to 2.4. Therefore AD is equal to 2.4 centimeter. Now let's move on to the next question. That is question number 2. E and F are points on the side PQ and PR respectively of a triangle PQR. Okay, this figure is not for this question. This is for different question. Here what the question says is E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. Okay, so here what the question says is in a triangle PQR, E and F are points on the side PQ and PR. Here E and here F. Now we're going to see whether a line through this will be parallel to this line or not. Here this diagram, this figure is for different question. Here in Roman number 1, it is given that B is equal to 3.9. This is 3.9 centimeter, and EQ is 3 centimeter. EQ is 3 centimeter. PF is 3.6. PF is 3.6. And FR is equal to 2.4 centimeter. FR is 2.4 centimeter. Now what we're going to do here is we will check whether EF is parallel to QR or not. And here in this case we're going to use the converse of basic proportionality theorem, which says if the ratios are equal, then only these two lines are parallel. if the ratio, that is BE by EQ, is equal to PF by FR, then these two lines will be parallel. If PE by EQ is equal to PF by FR, then EF will be parallel to QR. Okay, so let's first find PE by EQ. PE by EQ. Now here PE is 3.9 and EQ is 3. Now you can cut 3 ones are 3, 3 ones are 3, 3 threes are 9. So we got here 1.3. Now again let us check BF by FR. PF by FR. Now PF is 3.6 and FR is 2.4. Now what we can do here is, there is equal number of digits after this decimal point. Here we have 1 digit, here we have 1 digit, so we can remove the point. 224. Now we will cut this by 6. 6 fours are 24, 6 6 are 36. Now you can cut by 2. 2 twos are 4, 2 threes are 6. Now this is 3 by 2, which is equal to 1.5. 1.5. 3 divided by 2. Now we can see that these two are not equal. This is 1.3, this is 1.5. So since these two are not equal, since the ratio here, this one and this one are not equal, this line is not parallel to this line. Here PE by EQ is not equal to PF by FR. Therefore EF is not parallel to QR. Now let's see the second one, that is Roman number 2. Here PE is 4 centimeter, QE is 4.5, PF is 8 centimeter, and RF is equal to 9 centimeter. Now we're going to check PE by EQ. This is equal to 4 by 4.5. 4 by 4.5. Now here we can write 40 by 45. Now after this point, decimal point, there is 1 digit, so you can write 0 up here. 1 0. Now you can cut by 5. 5 8 are 40, 5 9 are 45. So we have here 8 by 9. Now for the other side, PF by FR. PF by FR is equal to, PF is 8, FR is 9. So we have here 8 by 9, here also 8 by 9. Therefore PE by EQ is equal to PF by FR. So since the ratios of this and this are equal, now we're going to say this implies that EF is parallel to QR. So since we're using converse of basic proportionality theorem. Now we'll see the third one. We have PQ is equal to 1.28. PQR. PQ is 1.28. 1.28. This is PQ. and PR is 2.56, 2.56, and then we have here E and F, EF. PE is 0.18, 0.18, and PF is 0.36, 0.36. Let's find out PE by EQ. PE by EQ. Now we have PE is 0.18, 0.18. EQ is not given, so we can find out EQ by subtracting this by this, because from P to Q is 1.28 and from here to this portion is 0.18, so the remaining portion will be this minus this, PQ minus PE. So we have here 0.18 by PQ is 1.28, 1.28 minus PE is 0.18. Now if we subtract this, 1.28 minus 0.18, so we get here 1.10. This is 0.18 by 1.10. Now, as I have told you earlier, after the decimal point we have 2 digits here, and after the decimal point again we have 2 digits. So since the number of digits after the decimal point is same, we can write here 18 by 110. Now this one we can cut by 2. 2 5s are 10, 2 5s are 10, here 2 9s are 18. So here we get 9 by 55. Now for the other side, PF by FR. PF by FR. Now PF is 0.36, 0.36, and FR, this FR again we can write PR minus PF, PR minus PF. Now this is 0.36 by PR is 2.56 minus PF is 0.36. Now this gives us 0.36 by, now 2.56 minus 0.36, get here 0, 2, 2, so 2.20. So now after this decimal point we have 2 digits, and after this decimal point we have 2 digits, so we're going to remove the point. So you have here 036, which is 36, and you have here 220, 220. Now this you can cut by 4. 4 9s are 36, 4 5s are 20, 2 remainder, again 4 5s are 20, so we get here 9 by 55. Now what we have here is PQ by EQ is 9 by 55, and PF by FR also is 9 by 55. Therefore PE by EQ is equal to PF by FR. So now since the ratios are equal, now we can say that these two lines are parallel. So this implies EF is parallel to QR. This is by by converse of basic proportionality theorem. Now let's see question number 3. In this figure, if LM is parallel to CB, LM is parallel to CB, and LN is parallel to CD, LN is parallel to CD, then prove that AM by AB equal to AN by AD. AM by AB is equal to AN by AD. Now A, B, C, D, E. Basic proportionality theorem is if these two lines are parallel, then AD by DB is equal to AE by EC. So here AD by DB is equal to AE by EC. Now what we can get from this main theorem is this is corollary. Now if we take AD by AB, AD by AB here like this, then in the same manner if we take on the other side, the ratio will be same. So this is 1. Or we can also take DB by AB. DB by AB is equal to EC by AC. EC by AC. So in whatever manner we take the ratio on one of the sides, if we take in that same manner on the other side, the ratio will still be same. So that is the corollary of basic proportionality theorem. Now let's consider this first triangle, this triangle ABC. In triangle ABC, LM is parallel to BC. LM is parallel to BC. These two lines are parallel. So this is given in the question. Now since these two lines are parallel, here we will get AM by AB. AM by AB. This is what I said just now. The corollary, we are using this property. So here since we are taking AM by AB, here also we have to take AL by AC. AL by AC. This is given by basic proportionality theorem, PP theorem. Now let's call this 1. Now again in the second triangle, that is this triangle ADC. Again in triangle ADC, in this triangle, these two are again parallel as given in the question here. LN is parallel to CD. This is again given. Therefore here also we are going to take AN by AD. AN by AD will equal to AL by AC. AL by AC. Now this is given by basic proportionality theorem. Let's call this 2. Now from 1 and 2, now AL by AC is equal to AM by AB. Again the same AL by AC is equal to AN by AD, which means these two are equal. So AM by AB is equal to AN by AD. So this is what we have to prove. Yeah, this is the one that we are supposed to prove, so we have proof here, so hence proof. Now let's move on to the next question. Now here in the figure, DE is parallel to AC, DE is parallel to AC, and DF is parallel to AE, DF is parallel to AE. So we have to prove that BF by FE is equal to BE by EC. To prove is BF by FE is equal to BE by EC. Proof. Okay, now let's take the triangle BEA, this triangle BEA. Now in this triangle, DF is parallel to AE. This is given here. DF is parallel to AE. So in triangle BEA, DF is parallel to AE. Now since these two lines are parallel, now we can say that BE by FE is equal to BD by DA. So what we have here is, these two lines are parallel. Now this is BEA, and this is DF. Now since these two lines are parallel, the ratio of this one and this one will be equal to the ratio of this one and this one. That is the basic proportionality theorem again. So therefore BF by FE is equal to BD by DA. BD by DA. This is basic proportionality theorem, that is PP theorem. Let's call this one. Now next we are going to take this big triangle, the whole triangle here, and in this whole triangle DE is parallel to AC. DE is parallel to the AC. That is given in the question here. That is given in the question here. So in triangle BCA, DE is parallel to AC, given, since it is given. Therefore, so now again our triangle is this big triangle. Now this is D, and here we have, this is A, this is B, and this is C, this is D, this is E. Now in this triangle, these two lines are parallel, that is D is parallel to AC. So we will have here BE by EC is equal to BD by DA, basic proportionality theorem. So BE by EC is equal to BD by DA, BD by DA. This is a basic proportionality theorem. Now let's call it 2. Again from 1 and 2, we have BD by DA equal to this. Again the same BD by DA equal to this. So we will get this one is equal to this one. So from 1 and 2, 1 and 2, we get BF by FE is equal to BE by EC, which is what we are supposed to prove here. Hence proof.